So today we're going to be going over questions 6 and 7 on your last exam paper. So question 6 says the following. The gradient of the normal to the curve y equals ax squared plus bx minus 10. So first of all, I'm going to write this down. Ax squared plus bx minus 10 at point 24 is minus 1/3. Now this is quite complicated because we've got the starting function, but we haven't got the differentiated function. So if we want to find the gradient of something, what is the gradient of a function? There's two ways of which we can approach this. Number one, if we've got the function y equals mx plus b, the gradient is always m. Whereas with this kind of function, this is really difficult because the gradient is obviously changing all the time because this is a quadratic graph. All we know about this quadratic graph is, first of all, it's a smiley face. And we know it's a smiley face because we have got probably a positive a, but we don't actually know if it's positive a. That's just an assumption I'm making. It doesn't say a is positive. If a was negative, it would look like a sad face. And we know that at 0.24, so roughly this, 24, it's going to have a negative gradient. And we also know it goes through minus 10. So it's going to go through minus 10. So there is quite a lot of information we don't know. So if we want to find the gradient of a function, like we said, we can't do it with y, because what you have to do is find y dash for this. The reason why we have to find y dash is because y is the original function and differentiating y will give you the gradient function. So let's do that. So first of all, we've got to differentiate this. Now this might scare you because we're differentiating with algebra. So we're going to take the x squared and we're going to differentiate it. That will obviously be 2x, but we've got the a involved as well. So it just becomes 2ax. And then if we differentiate bx, that just becomes b. And then obviously a number differentiated disappears. So the first bit of information, it says the gradient is this at this point. So what we're going to do, and this is where it gets a little bit tricky. dy by dx is the gradient of a function. So we're going to say that minus 1/3 is the gradient. So we substitute that in there, minus 1/3. Now what can be confusing about this is we're only going to substitute, I believe, the 2. Because what we're substituting for the left-hand side of the equation is the gradient, not the y. So then we're going to start substituting in the x. So the x is 2. So we just do 2 lots of a times 2. So this is this 2 here, plus b. Yes?
The minus 1/3 is the gradient of the normal.
The gradient of the normal. Fantastic correction. So well done. So it actually shouldn't be minus 1/3. Thank you for the correction, because that would have gone really wrong. That actually should be 3. Do you agree with that?
Yeah.
So in the exam, because it said at 0.24 is minus 1/3, that's at the normal. One of the points you had to do before you substituted it in would be to find the reciprocal of minus 1/3. What do I mean by that? Well, minus 1/3 times by something, which is going to be the gradient of the tangent, is going to be 1. So that is called finding the reciprocal. So what we do is we just flip it and change the sign. So actually, if we go back to the original graph, the gradient of the normal is indeed going to be minus 1/3, and then the gradient of the tangent was going to be 3. So we're probably looking at a graph that's going to look a bit like this. Now, what is the difference between a normal and a tangent? Let's change my colour of the pen of how we're going to do this. So first of all, the tangent sort of touches the graph and goes in the same kind of direction to it. That is what we call the tangent. We have covered that quite a lot. But the normal goes through at a right angle. We haven't covered that a lot. So this is why we're doing this today. I've covered this individually with you, but not really as a whole class that frequently. So there's the normal. So obviously when we're dealing with a gradient function, you have to change it into the tangent format. So now we're going to simplify this equation. 3 equals 4a plus b. And from the mark scheme, I think that's correct. If you disagree with that, put your hand up at some point and we can put a correction for that. So now we have one equation. We're not very happy with the equation because we have 2 unknowns. So we have to set up a secondary equation to start solving it. The secondary equation is going to just be the original equation. So wherever there's a y, we're going to replace it with a 4. Wherever there is a x, we're going to replace it with a 2. So we get 4 equals 4a plus 2b minus 10. And then we have 2 simultaneous equations that we need to solve. I'm going to wait a moment or so for someone to check that on the mark scheme, but I believe both of those are correct. Now we need to simultaneously solve this system of equations. Because I do not have access to a calculator on this screen, I am just going to manually solve these, and they're quite easy to solve. Why? Because we've got 2 lots of 4a, and these are matching each other. Obviously, if you were to do it on the calculator, you need to go on to apps, simultaneous equations, and then put them into a matrix. How do we put them into a matrix? Well, we would do 4, 1, 3, variable 4, variable 1, then 3, and then on the second line would be 4, 2, and then because you have to put this onto the other side, that would be 14, and you would just be solving that. So we're going to minus the top equation from the bottom equation. We'll do 4a minus 4a, 0. 2b minus b, that's going to be clearly b. And then I'm going to imagine I've manipulated the minus 10 onto the other side, so it's 14. 14 minus 3 is 11. I'm hoping this is correct. Fantastic. Then, once we've got the 11, we're going to just substitute it back into one of the equations, and we just take the 11, and we're going to do 4 lots of a plus 11 equals 3. So I've just substituted it into that, and you can see if you're good at algebra, it's probably quicker than using the calculator, and you're less likely to make mistakes. 4a is minus 8, and a is minus 2. And then that links with exactly what I thought. The graph is going to have a sad face, because a is less than 0. This is the correct answer. A is not greater than 0. It goes through minus 10 and it links with this pattern. So this diagram drawing here is completely optional, but you can see it links up. First of all, we have got a normal line which goes through this point at a right angle to the tangent. We could then check our answer if we can be bothered. Let's see if we've got a bit of time to check our answer. So we think our function is y equals ax squared plus bx minus 10. A is minus 2, so we're going to have minus 2x squared plus 11x minus 10. First of all, if we were to find the normal, we would differentiate it. And then we're going to say that's minus 4x plus 11. I think that looks correct. And then we're going to find at point 24. So then we're going to sub in x is 2. So then whenever we have an x, we're going to put this, and then it gives us a gradient of 3. That's great. That matches with this 3. So the gradient of minus 1/3 is correct. And then another way you could check it is just to check both 2 and 4 work in the function. So we take y, we're going to put a 4. We're going to see if it equals when we put a 2 in. Minus 2, 2 squared plus 11 times 2 minus 10. This is a 3 equal sign to see if it works. 4 is minus 2 times 2 times 2 minus 8 plus 22 minus 10. 22 minus 18 is 4. That is correct. So that could be a check you could do at the end. Obviously, that's quite excessive. This video has been 9 minutes, which is about the amount of time you'd have in the exam. So if you can do it at my pace, you should be able to be okay. Has anyone got any questions that they want to be in the video?